Okay, so we have a cheetah accelerating from 0 to 30 meters per second in 7 seconds. I asked first what definition do we use to do this, okay? And nobody said the definition of acceleration, but people said things that were related to the definition of acceleration, meaning that you're not thinking in terms of definition, you're thinking in terms of intuition, and you want to do both, okay? Whatever your intuition is, though, take it back to the definition and make it rigorous. The problem itself isn't stated rigorously. It says, what's the acceleration of a cheetah that accelerates from 0 to 30 meters per second in 7 seconds? Cheetahs don't accelerate uniformly. Almost nothing accelerates uniformly except freely falling objects and things rolling down straight inclines, okay? And, you know, things under constant, uniform, constant force, okay? Constant masses, constant forces. And you can invent things that do that, but they don't occur in nature that often. They don't occur in machinery that often either. Okay, so there's your definition of acceleration, but we need the definition of average acceleration. Acceleration is a rate of change of velocity with respect to time. Now that means it's a limiting value of a delta V over delta T. Right? Change in velocity divided by change in time. Those are average accelerations. You have a delta V and a delta T. Okay? Your rate of change of V with respect to T is dV dt. dV dt is not the definition. This is the definition. dV dt is equivalent to the definition, but that's not how you want to do it. Because that's just a formula. It doesn't have meaning. The statement has meaning. Okay? We want to focus on meanings. When you get into, yeah, this is a very simple problem, but when you get into complex problems, if you're just focused on formulas, there are a lot of ways you can go wrong if you don't understand the meaning. Okay. So, well, now we can say, okay, delta V over delta T. Clearly, velocity changes by 30 meters per second in 7 seconds. That's approximately 4.3 meters per second squared. And you can just write that down intuitively. And you can be pretty secure with that rigorously you go back and make sure this is consistent with the definition. Okay? Actually, this definition. Well, delta V is your change in velocity, delta T is the 7 seconds. And intuitively you're going to want to divide this by this. And that's exactly what you're supposed to do because of the definition. So, relatively trivial problem. And you've done much harder problems where you have quadratic position functions and you had to figure out the set of equal and you did that. Okay? There's a world of difference in the sophistication between this, which you could ask anybody with an algebra background, and that, which takes pretty good mathematical sophistication and physical insight. Okay?